sign of this AB in the left. Now, if and hello students, welcome to my YouTube channel VRacademy. We were discussing about the digital electronics topics, various topics of digital electronics in the previous videos. Today we'll start with our topic of discussion, that is race around condition. It is one of the very important topic. I mean, many of the students have various types of confusion regarding what exactly race around condition is, why it is occurring, and how to resolve race around condition. So all these questions will be answered in this session, and it is this will lead to a new type of flip-flop which we are going to discuss in the next video, and if time will permit, we'll try to discuss it in this video only, but if not, we'll be moving to the next video and there we'll be explaining about that flip-flop. But for the time being, we'll only try to understand what exactly race around condition is. So we'll try to go for its definition and all, and where it is occurring, all these things we have to know. So prior to going for this race around condition, I want to just recall you one thing. In the last videos, during the explanation of JK flip-flop, I have said you that if J was equal to K was equal to 1, at that time, the output of JK flip-flop was expected to be toggle. Or you can, what is toggle exactly? It is the complement of the last state. So that is the condition. That means if J is equals to K is equals to 1, the output is expected to be toggle. Output is expected to be toggle. Okay. But what happens and why race around condition occurs? We'll try to learn that. See, now whenever we are going for any kind of sequential circuit or even combinational circuit, we are designing it with the help of gates. So a minimum time is required for the transition of signal from the input to the output, isn't it? So that time period is called as propagation time period. I mean, the time required by the signal, or you can say time required for getting the input to appear as the output. So that is called as propagation time period. So that is going to play a very vital role. Two topics are going to play a very vital role by explanation of race around condition. One is propagation time. I am telling that one as TP, okay, and the other one is time period of the clock signal, that I am telling as TC, okay, clock time period. So these two are going to play a very vital role during the explanation of race around condition. Now what happens, you see, let us suppose we are having a clock signal. We are having a clock signal like this. Generally, I have already explained you, clock signal are square signal, are in the form of a square signal, and this is the time period of clock which we are describing as TC. Now this time period is called as T on, for the time period for which the signal remains at the higher state. Now this is T on. Similarly, we can go for propagation time, and I am telling that time as this one. This is, let us suppose this is our time period of propagation that we are calling as TP. Now if such is the condition where you will be finding out that T on is greater than TP. T on means half of the time period of the clock signal, or you can say TC by 2 is greater than TP, propagation time. Then in that case, what happens? You just try to understand the problem. If such is the case, what happens? You are getting the output. You are getting the output within this range of time period. You are getting the output within this range of time period. This range of time period. But up to this time also, your clock remains in higher state. Okay, and we know that at that time J is also and K is also equals to 1. So what happens in this time period also, we are getting the output as toggle once again. So once we are getting the output, let us suppose we are getting the output as 0. In the same clock interval, we'll be getting it as 1. And it totally depends on what is the width of TP, or you can say what is the propagation time period. If it will be much more smaller, we'll be getting it once again, it will be 0, once again it will be 1. So it totally depends on if propagation time period is going to shrink and this clock time period will become larger, then in that case we'll be getting the output which will be fluctuating between 0 and 1, which will be fluctuating between 0 and 1. Now this fluctuation is known as race. This fluctuation or this condition is termed as race condition or race around condition. Race around condition. Race around condition. So for getting the race around condition, a very obvious thing is that you have to keep in mind 2-3 things. The first thing is that your flip-flop should be level triggered. Means it should be triggered, or it should be operating when it is at the level. First thing. Second thing is the value of j and k must be equal to 1. And the third case is that the propagation time period must be smaller than the t on time period, means half of the time period of clock signal. So if these 3 cases will persist, our output is going to fluctuate between 0 and 1 for very large number of times, and that condition is described as race around condition. Now if you will just append all these 3 points, you will be able to get the description of race around condition. What you need to tell, if you will be asked what is race around condition in JK flip flop, so you will say it like ki race around condition arises if our JK flip flop is level triggered and the value of j equals to k equals to 1, and one more condition needs to be satisfied, that t on, that is half of the time period of the clock signal, must be very larger than the propagation time period of the signal. So if this condition persists, the output of flip flop fluctuate between 0 to 1 many number of times between a single clock pulse. That condition is described as race around condition. So this is about the race around condition, and why it is occurring you have understood. Now the next question will be, what is the solution to this race around condition? How it can be avoided? So the answer lies it over here only. Now if anyhow you will make propagation time period greater than or equal to t on time, if such is the case, if you will make propagation time bigger, or you can say larger, then in that case you can see that it will be, let's suppose, something like this one. So in that case you will be finding out it is smaller than the clock period. So even if it will be extended, you will be finding out you will be getting the output only one time. But this case, getting a TP greater than equals to T on is a difficult task. Means verbally we are telling it, but practically doing this is a difficult task. So next thing is, this is the first way by which we can resolve it. This is the first way. TP greater than equals to T on, or you can write it as TP greater than equals to TC by 2. This is also the same condition. You can write it like that one. The next condition is, I have told you that race around condition occurs if it is level trigger. I mean, if your flip flop will work over here, then there is a possibility of occurrence of what? Race around condition. So if you will make your JK flip flop, edge triggered. If you are making it edge triggered, then automatically this problem will be resolved. If you are making it edge trigger means your flip flop will either work at this point or will work at this point. If it will not work on level, there is no chance. We are not thinking about what is happening in this time interval. I will only think about what happens at this point, what happens at this point, nothing else. When signal goes from 0 to 1, when signal comes from 1 to 0, and it happens to be in a fraction of microseconds, so definitely it will not create a problem, and you will not have a problem of race around. But this is also, I mean, in most of the cases, this is the process which is being done. We are going for making the JK flip flop edge trigger. The last one is, or you can say the easiest of the method which can resolve the race around condition is use of master slave flip flop. I mean, master slave flip flop. Now here you need not have to make any changes in its edge triggering TP greater than T on. Nothing has to be done. Just by connecting two JK flip flops simultaneously and making one JK flip flop as master, the other flip flop as slave, you will be able to resolve this. We'll be discussing it about during the explanation of master slave flip flop, that how it is resolving that problem. But for the time being, I think I have said you and discussed about each and everything very clearly. That race around condition occurs due to 3 conditions. First one is level triggered flip flop, JK equals to 1, And third thing is that TP must be very, very smaller than T on, or that is TC by 2 or clock half of the clock period. So if such is the case, the output fluctuates between 0 and 1. That is known as race around condition. How it will be resolved? The first case is if you are making TP very, very larger than T on, then automatically that condition that problem will be resolved. And second thing is, do not allow JK flip-flop to work on level. Try to make them work on edge. If such is the condition, your race around condition will be resolved. And third and the most important thing, that will be using the master-slave flip-flop. Use of master-slave flip-flop for resolving race around condition will be discussed in detail in the next video. For this instance, I think you have got all the things. Thank you for joining. If you are having any doubt in this one, you can come up with that. Thank you.